Hoping to lure more shoppers downtown, a city builds a new public parking garage in the central business district. The city plans to pay for the structure through parking fees for a random sample of 44 weekdays. Daily fees collected averaged $135 with a standard deviation of $14. Complete parts A through E below. Okay, so what assumptions do we need to make in order to run the t-test, the t-interval? So we definitely need to have a distribution that's unimodal and symmetric without any outliers. At least 10% of the population? No, definitely does not need to be at least. In fact, if it gets too big, it actually messes us up, so we don't want that one. Data are a random sample of all days? Yes. And it says it's a random sample of 44 weekdays. And the data value should be dependent? Nope, they actually need to be independent, so we are good on that. So I'll be honest, one of the harder parts of this is probably not actually computing the interval itself. That's not too bad, just using the technology. The harder part is sometimes these add-on questions. What do the assumptions mean? What does a 99% confidence interval actually mean? So make sure that you sort of pay attention to that part of the problem. Okay, so let's go ahead and compute this. I'm going to use StatCrunch. So view an example, StatCrunch. So I'm going to go to stat, tstat, one sample with summary. So we have the mean of 135. Standard deviation is 14. And the sample size is 44. Confidence interval. And it says to use a 90%. And compute. So there is our interval. Lower, and let's look at the rounding. Round to 2 decimal places as needed. So we have 131.45, and the upper is going to be 138.55. 138.55. Now let's interpret this confidence interval in context. So think about what this interval means. So we're 90% confident that the true mean falls somewhere in this interval. So that is 90% confident the interval contains the daily mean. That's it right there, D. These are really close together. Just make sure you kind of see the differences between all those. Explain what 90% confidence means in this context. So I'm going to show you something here. I can go to Applet's confidence intervals for a mean, and this pops up. I can select normal distribution, population mean of 135, standard deviation of 14, initial confidence level 90%, my sample size, and I can do my t-interval and press compute, and it will actually simulate what that means. And I can sort this graph. So here we simulated it, and 88 of the 100 contained the true mean. So these red ones did not contain the mean. If I sort this, it looks a little better. Some overshot it, some undershot it, and did not contain the mean. Let me do it again. Another 100 intervals. Actually, let me reset it so you can see what's going on here. 100 intervals. This one, 91 contained the mean. And 9 of them didn't, so about 91%. I could do 1,000 intervals. Again, let me reset it. 1,000 intervals, and it just shows me the last one. And close to 90% of them contained the mean. This is the last interval containing the mean. Okay, so that's what the confidence interval actually means. So that about 90% of all sample size 44 produce intervals that contain the mean income. That one. So the consultant who advised the city on this project predicted that the parking revenues would average $143 per day. Based on your confidence interval, do you think the consultant was correct? Why? So his prediction falls outside of our interval. So since the 90% confidence interval does not contain this 143, the predicted average, the consultant's prediction, is not plausible. If it had been, like if it had been $135, then it would be plausible because their confidence interval would contain the mean. So I hope that helps.